What is projectile motion? Projectile motion is a path an object follows through the space as a function of time. In simple, projectile motion is any object that once thrown or dropped continues in motion by its own inertia and is only influenced by the downward force of gravity, G. Now you must be wondering, what is inertia? Newton's first law of motion states that an object in motion tends to stay in that motion unless it is acted upon by an unbalanced force. The object tends to keep on doing what it is doing. In this case, it's not moving. This tendency to resist changes in their state of motion is known as inertia. What makes projectile motion so interesting that we learn in class? Imagine an ideal situation and neglect air resistance. Then all objects will fall to the ground at the same time with uniform acceleration. So if we have a 5 kilogram bowling ball and a feather that's weighing 0.0005669 kilograms, and they were both dropped from the same height at the same time, they would both land on the ground at the same time. Firstly, there are two types of projectile motion. The body, although is one, has two types of velocities. Velocity in the vertical direction and velocity in the horizontal direction. The vertical motion is influenced by the force of gravity. The horizontal motion is with constant velocity. Hence, the motion of the body is of two types, with constant velocity motion and variable velocity motion. An object is controlled by two independent motions. So an object projected horizontally will reach the ground at the same time as an object dropped vertically. So no matter how large the horizontal velocity is, the downward pull of gravity will always be the same. So with all the background knowledge on projectile motion, I'm going to introduce you guys to two projectile motion problems that are very important to learn. So firstly, before you even get started with the first problem, I'd like to point out you should always have a reference frame for a problem like this. So because most of our motion here is going to be down, I'm going to put down as positive and up as negative. And you'll see later on why our positive and negative reference frame is really important when I do the maximum vertical height problem for our second problem in this video. So our first problem is, Bubba the runner jumps off a cliff that is 200 meters high. He runs at 10.0 meters per second off the cliff into the water. So this is the written out problem for the first problem I gave you guys with the diagram earlier. So it asks us, Bubba the runner jumps off a cliff that is 200 meters high. He runs at 10.0 meters per second to the right off the cliff into the water below. A. How long does it take Bubba to hit the ground? A useful equation to find that would be delta D is equal to V1 delta T plus 1/2 A delta T squared. Second question asks us, how far from the base of the cliff does Bubba land? Basically, he's asking for his range. Useful equation for that would be delta D is equal to V1 delta T plus 1/2 A delta T squared. C asks us, what is the final vertical component of velocity for Bubba? A useful equation for that would be V2 squared is equal to V1 squared plus 2A delta D. And finally, D asks us, what is the final impact velocity angle always relative to the horizontal? A useful equation for that is c square is equal to a square plus b square, and tan theta is equal to y. So for part A, for the first question, we have the givens. V1x is equal to 10.0 meters per second, delta dy is equal to 200 meters, b1y is equal to, or assumed to be, 0 meters per second, and delta t is unknown. So the useful equation I gave is right here. And then when we sub in, we get 0 meters per second here for v1 delta t, so that part cancels out. And then, so delta dy is equal to 1/2 A delta t squared. When we solve and rearrange the equation for delta t and sub in all the values that we have, we get 6.385 seconds, or approximately 6.3 seconds. Therefore, it takes Bubba 6.3 seconds to hit the ground, which is, in this case, water. Part B for question 1, it's very simple. So because we are only talking about the horizontal component of velocity, this part of the useful equation I gave cancels out. Then we have the givens which is v1x is equal to v2x, which is equal to vx, which is equal to 10.0 meters per second to the right. Time is 6.385 seconds. Delta dx is unknown. When we sub in the known values into the equation, we get 63.85 meters, or approximately 63.8 meters. Therefore, Bubba will land 63.8 meters from the base. Part C for question number 1, we have the givens. v1y is equal to 0 meters per second. Ag is equal to 9.8 meters per second squared. Delta dy is equal to 200 meters. When we sub all these values into the equation I gave above, we get 62.64 meters per second, or approximately 62.6 meters per second, v2y. Therefore, the final vertical component of velocity for Bubba is 62.6 meters per second. For the last question, part D, in question number 1, the givens are v2y is equal to 62.64 meters per second, v2x is equal to 10.0 meters per second, v2 is unknown. We are trying to find the angle theta and the speed at which he hit the ground for v2. So theta is unknown, v2 is unknown. We know the horizontal and vertical components of velocity. When we sub it into the Pythagorean theorem for vertical and horizontal components of velocity, we get 63.43 meters per second, or approximately 63.4 meters per second. Then we take that, and so we have the vertical component of velocity. Now we need to find the angle at which the velocity was. So we use tan theta is equal to y over x. We sub in our values and multiply y over x by tan inverse. We get 80.92 degrees, or approximately 80.9 degrees. Therefore, the final velocity of Bubba is 63.4 meters per second, 80.9 degrees below horizontal, BH. For question number 2, Bubba is running off the same 200-meter high cliff at a velocity of 10.0 meters per second, 45 degrees above the horizontal. And the trampoline, he jumps off a trampoline that is 0.5 meters high. We will assume that this trampoline is not very good and is very stiff, so it's just another platform for him to jump off of. And you'll see in this question, when I'm trying to find a maximum vertical height, and in my solutions, you'll see why a positive negative reference frame is really. So for problem number 2, Bubba is running off of the same cliff, but this time he jumps off of a trampoline that is 0.5 meters high while going forward at a velocity of 10.0 meters per second, 45 degrees above the horizontal from the 200-meter tall cliff. So I'll give you guys a second to look at the question. For this part is where the positive negative reference frame is very important. The solution to question 2A, 2B, solution 2C and D, and solution E.